here's an analogy to what that projection looks like, just one dimension lower. So let's just say, for example, you had to do a double integral, and let's say that d is described this way. So we've got, let's just say there's, yeah, how about this? You've got, let's say there's 9 right there, and you've got this graph, so the sideways half parabola, y is equal to root x, and then you also have, let's just say, for the sake of simplicity, this line, y is equal to negative x. So then you've got this region, so x-axis, y-axis, x-coordinate 9, right? So you've got this line here, x is equal to 9, and so the region, let's say, is this one right there, okay? And so that's the region D. So to set this up, let's say you had to set up as a dy dx integral. So we want the x integration to happen last. This is ideal, actually, because if you look, for a typical x value, you'll notice that the upper y value and the lower y value are always given by the same, the upper y value is always given by the same function, root x, and the lower y value is always given by the same function, negative x. You could set this up as a dx dy instead, but that's going to actually require setting up several double integrals. So this is going to be easiest, right? So let's just mention here why this will be easiest, because it's easy, or rather convenient, to say the min and the max y values in terms of x. Okay, so what we're going to do is set up an integral, something to something, integral. We know that, okay, well, so this is going to, let's, end this dy dx. So y is going to go at the lowest from negative x all the way up to root x, okay? And so the thing is, once these here are done, so, right, we know what belongs right here and right there, yeah, from the picture directly. Then, to find these, and by these I mean now where there's just little squiggles, to find those, project y away. Okay, so what does that look like? So I'm going to redraw the picture that we had, really, essentially. Okay, so as a rougher picture, we had sideways half parabola, vertical line, slanted line. There's a shaded region here. I'll try to just lightly shade this right now. Okay, so the idea is to stand stand here where the y-axis is, and if you look down, and let's say you lose all sense of depth perception, all you're going to do is when you project, so a point like here that's above the x-axis is going to project down to here. So all of the points that are here are going to project down here. The points that are below, like these points, are going to project up to here. And in the end, what you get is just this line segment right there. Right? In the end, you get just the line segment. And the x values are always in the closed interval 0 to 9. Okay, and so that ends up being the values that we put on the integral. So now we know of integral 0 to 9, integral negative x to root x of whatever the function is, f of x comma y, dy dx. So the key point is to take this object here and just basically push it in. Push it in, squish this Play-Doh down until all of the points live on the x-axis. The point is that we're going to do the same thing one dimension higher.